To a computer, an image is a collection of pixel values, which are just numbers. And since computers are really good at crunching numbers, we can use them to build AI models that process and analyze visual information. One way we can approach this is to start with a set of labeled training images containing pictures of things we want the model to recognize. Next, we add a layer of filters, each initialized with random weights, and we feed the images through the filter layer to generate feature maps based on the outputs from the filters. We can add as many of these layers as we want to, each producing a new set of feature values for the images. We can also add layers of special filters that pool or downsize the feature maps to reduce their size by emphasizing the most prominent features they've extracted. The result is a set of smaller matrices of values that represent the visual features found in the images. Next, we flatten the feature maps into a single array of values so that each image is represented by a vector, and each element in the vector is a feature of the image. Now we can feed the vector of features into a fully connected neural network, which applies its weights to the feature values and feeds the data forward through the layers of nodes in order to generate a prediction for each image. The predictions are typically vectors that represent a probability distribution, with each vector element indicating the probability that the image belongs to a particular class. At first, the predictions will be more or less random because of the random weight initialization in the filters and neural network nodes. But since we already have the labels for the training images, we can use backpropagation to adjust the weights and keep repeating the training process until we have a network that predicts acceptably accurately. Then we save the trained weights as a model, which we can use with new images to generate predictions, for example, to classify images based on their contents. This approach to training a computer vision model is called a convolutional neural network, usually abbreviated to CNN, and it's been at the heart of some major advances in computer vision.